Hello.
How are you?
I'm good. How are you?
Good. You're back in school, right?
Mm-hmm.
So, how's your geometry class started?
Easy.
Okay, good. That's good to hear. Do you have a textbook?
Yeah, I do have a textbook.
Who are the authors on the front page or the front cover?
Let me pull it out real quick. It is Holt McDougall, Larson Geometry.
Yeah, Larson, Boswell, and Stiff are
Yeah.
authors of the book I have. Good. That'll make it easier to help you when you get to reasoning and proofs, which you probably aren't at yet. In other words, you probably are just still on chapter 1, right? The basics of geometry?
Mm-hmm.
Okay. All right. Well, if it's easy, then I would suggest that this week we just continue on as is.
Mm-hmm.
And the moment you need or want to start covering what you're covering in class, in other words, that you need help with it, let me know, and you can just take or tell me what chapter you're working on and what problems you're having difficulty with, and we can go straight to that.
Okay.
I would suspect you're not going to have any problems until you get to the proofs, which probably won't be for another week or two. And even then, you may not have that much problems with it. Most of my students don't like the proof chapter. It's difficult to understand. It's different, really, than the geometry we've been doing. The geometry you need to know for the ACT test and the SAT test is the stuff we are covering or have covered this summer. So you can never go wrong by covering this stuff here.
Okay.
Okay. Let's look at number 6. We have a triangle and we have a circle. Circle has a diameter of 5. The triangle has a base of 5. And they have equal areas. They want to know what the height of the triangle is. And we don't need multiple choice here. What's the area of this circle? It's the general formula.
Pi r squared.
So what is it for this circle?
2.5 pi squared, or pi times 2.5 squared.
Okay, it's 2.5 squared times pi, which is 6 1/4 pi. 2.5 is kind of a good one to memorize. What you get when you square 2.5, you get 6 1/4.
Okay.
So that's the area of the circle. Well, that's the same area of the triangle. What's the general formula for the area of the triangle?
Base times height divided by 2. Or 1/2 base times height.
Same thing. And they're telling us that it has an equal area, so its area must be 6.25 pi. And we know it has a base of 5. There's only one unknown there, h. So, what's the best way to solve for h?
I'm not sure.
Well, it's a very basic algebraic equation. When I'm solving algebraic equations, the first thing I look to get rid of is any denominators. Okay, well, we have a denominator right there. So let's multiply both sides by 2. Well, that's easy enough. That's 12.5 now. When I multiply it by 2, pi equals 5h. What's the next step for solving that equation for h?
Divide by 5.
So 12.5 divided by 5, pi equals h. That looks like 2.5 to me.
Mm-hmm.
2.5 pi should be our answer. 5/2 pi. Okay. All right, let's go to the next page.
Yeah, so far everything about the class is clicking pretty well. So
Everything about the what?
everything about the class is clicking. So
Oh, good. So this figure has 4 squares, 4 triangles, and 1 rectangle. Here's the squares, 1, 2, 3, 4. Here's the triangles, 1, 2, 3, 4, and there's the rectangle. What is the perimeter of the entire area? Hold on. Well, the perimeter, we're only caring about the outside. So this line right here, the top of that square, what's that equal to?
3.
What's that side equal to right there?
4.
Same side over there. Haven't figured out the slanted parts yet. So let's figure out the slanted parts. What is this hypotenuse here? If
3 squared plus 4 squared equals whatever it is. So a squared plus b.
right, but remember your basic triangle that they're going to present you all the time is a 3, 4, 5 right triangle. Okay.
Oh, so it's just 5.
So we know, we know that that little triangle there, this has to be 4, this has to be 3, that has to be 5. It just saves you, calculations if you recognize a 3, 4, 5 triangle, or, it can be a 6, 8, 10 triangle, or a 30, 40, 50 triangle. Any multiple of 3, 4, 5 is what they're inclined to give you with these kind of problems. And that's going to be throughout your entire geometry course. They love 3, 4, 5 triangles. So learn to recognize them.
Okay.
So this triangle is the same as the other 3 triangles because they all are 3, 4, 5 triangles. So that's 5, that's 5, that's 5, and that's 5. So now we have what? We have 12, 26, and 8. There's your perimeter. Oh, this one looks like a nice one. Well, I need to think about this for a second here.
Can't it not be determined?
possible that that's the answer. But let's examine things here. Let's see if we can determine that. It doesn't have to be a right angle. They haven't specified any right angles. But what they have said is that these are rectangles. So each of these are right angles. Angle 1, angle 2, angle 3. What are the sum of angle 1, angle 2, and angle 3?
$180.
Let's take this piece up here. That's angle 2, that's also angle 2. So angle A is equal to angle 2. See that?
Mm-hmm.
Merely because they're vertical angles. In other words, whenever I take two lines, that angle 1 is equal to that angle 1, and that angle 2 is equal to that angle 2.
Yeah.
So that's why they're equal. Now, this angle 1 over here is not equal to this. You can see that. In other words, angle 1 is acute,
Mm-hmm.
and angle C is obtuse. But what do I know? I know that 1 plus C is equal to what?
$90.
Well, what's all four of them equal to? $360.
Okay.
In other words, whenever you have a bunch of angles and they form a complete circle around a point, their sum is 360. Well, we know that two of them are 90. Therefore, 1 plus C must be 180. Same thing with B. It's clearly not equal to 3. 3 is acute, B is obtuse. But once again, the sum of these angles is equal to 360, and we know we have a right angle there and a right angle there. So B plus 3 must be equal to 180. Now, can we do anything with that information?
No.
They're all equal to 180. So I can say 1 plus 3 plus A equals 180. And I can say 1 plus C equals 180. And I can say 3 plus B equals 180. Now, without solving that, let's see. It looks like we have 3 equations and 3 unknowns. But in fact, 1 is unknown, 3 is unknown, and 1 is unknown. So we really have 5 unknowns and 3 equations. So I'm doubting we can solve for that.
Mm-hmm.
So you're probably right. It cannot be determined. Although I'm not positive, this could be one of those tricky problems where In other words, C is clearly equal to 3 plus A. Well, no. C plus A may be equal to B. I don't know. I don't want to spend all of our time seeing if we can solve this, but I'm inclined to go with that, but I'm not positive. That might be not the correct answer. What could be the correct answer? 360 seems to me to be what I believe is going to be the correct answer. Hold on a moment. All right, let's look at this a little different way. I think there is a correct answer. If we know that 1 plus 2 plus 3 equals 360, 180, excuse me.
Mm-hmm.
Well, what about this angle plus that angle plus this angle? Each one of those is equal to 360. We're subtracting 180, so we really have 1080 minus 180. So those three should be equal to 900 degrees. Those three outside angles.
Huh.
You see that?
Yeah.
Because each one of them, this is 360. So I would have that 360 plus that 360 plus that 360 minus angle 1 minus angle 2 minus angle 3. Well, that's where I get the 1080 is the 360s minus the three interior angles. That's 900. Now, we've also got, we know a right angle there we have to subtract. We have a right angle there that we have to subtract. That one, that one, that one, and that one. So I have to take my final answer and subtract off 6 right angles. Well, 6 times a right angle is that, and it gives me an answer of 450, and that's not on there.
Yeah.
Oh, I was so sure that it would be. I think that's a correct logic, actually. But it's not the right answer. I wonder if I did my math wrong. Let's see. 3 times 360 is 1080. Minus the interior angles is 180. Gives you 900. And then you still have to subtract off that right angle, 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 and that right angle, which is 6 right angles. Seems like 450 should be the answer.
Yeah.
Oh well. We won't dwell on it. I'll see if I can find the answer and see what their explanation is. That's a good problem.
Wait a second.
What?
I did 900. So if you take 90 times 6, you'll get 540. If you take
it's not 450. I did my math wrong.
360.
Yeah, and that answer is on there.
Yeah.
Very good. Good catch. 360.
Sorry, I just did the math on my calculator because it didn't seem right.
I don't know where I got 6 times 90 was 450.
Even if you were subtracting like 440 or something like that, you wouldn't end up with a 50 answer.
Well, good for you. That's great. That's great. That's really great, actually. Yeah, you might like geometry.
I really do like it a lot better than algebra.
More than algebra. Although I have to say that geometry is half algebra. A lot of your geometry problems you're not going to be able to solve without using algebra. But
I find geometry better to use my algebra with, just because I have something like
I can see
something to look at and I can apply it to.
Uh-huh.
Just algebra, it's like so theoretical almost.
Yep. No, that was a good get on that last problem. All right, let's see. We got time for another one or two here. A shaded area problem that I tell everybody that shaded area problems are subtraction problems because we don't have the mathematics to figure out the area of that shape. But we do have the mathematics to figure out the area of the circles, or the semicircles. So what I want to do is take the area of the entire object and subtract out the area of the two semicircles. Problem is what the heck is the area of the entire object? Well, this is a little more difficult one, but still very doable. Notice that if I drop a line vertical right there, now I have a rectangle.
Oh.
And so if I can figure out the area of that rectangle and subtract out that quarter circle and that quarter circle, I'm going to have the area of that.
So it'll be 7 by 14.
That triangle or that rectangle is what?
7 by 14.
Has a radius of 7.
Oh, yeah.
So 7 by 14.
Yeah.
Well, you're way ahead of me today. So that's 98. And then I need to subtract out 2 quarter circles or a half circle. What's the area of the full circle?
First, the full circle is 49 pi.
Okay, so I'm going to subtract out half of that. So half of 49 pi is 24 and a half pi.
So 73.5.
Is that what you get when you do 98 minus 24 and a half pi?
I believe so, yes.
Or is that what you got? What'd you come up with?
73.5.
Well, that's 24 and a half times pi, probably. Right? Because pi is about 3. And then I got to subtract that number from 98.
Yeah, I just did 98 minus 24.5.
Well, it's 24.5 pi.
Okay.
Because the area of one of these full circles with a radius of 7 would be 49 pi. And we basically have half of one. So it'd be 24 and a half pi. Now the question is, why is that answer not on there? We have 98 minus a number that looks to be pretty close to 75. Oh, yeah, it is on there, 21. What's 24.5 times pi? Got to be 71.
Yeah.
Subtract, or not 71, 77.
Okay. So,
And
21.
then your answer is 21.
All right.
Okay. Let's at least look at the next one. Ooh. These are tough. I don't even think this said the advanced section. I think this is supposed to be intermediate problems, but you know what this means? The arcs on all quarter circles are length pi.
Means all like the arcs of the quarter circles like are equal to 3.14.
Well, it's the measurement of say you wanted to know, if I had a circle here, and I wanted to know the distance from that to that as measured along the circle, what would that distance be?
One-fourth pi.
Depends on the radius, right? In other words, it's 1/4 of the circumference, and the circumference is 2 pi r. So that distance from there to there would be that divided by 4, or pi over 2 times r. They're telling us that that length is pi. So the radius of that circle must be 2. In other words, if I draw this and draw a line from there to there, it's 2.
Okay.
And since all radiuses are equal, that's 2. So basically, I want to take the area. Oh, they just want the perimeter of the square. Yeah, 16, easy. Yeah. Yeah, you are going to do well in geometry. I can see that right now. Good. Good for you.
Thank you.
Okay. I will talk to you next week. Now, if you run into stuff in class that you want to work on, send it to me in advance. Just or no, you don't have to, because I have your book. So just let me know what chapter it is, and if it's giving you confusion, we can go over it. And I don't know whether you or your mom plan on continuing these sessions through the school year or not.
Oh yeah, I think we do. Also, my mom is wondering how much she needs to pay.
Well, I pretty much decided I'm going to move my rates to 32. So once we get to September, it'll be 32 an hour or 16 per half hour.
All right.
Okay, as opposed to what I've been charging this summer, which was $10 per half hour. But I guaranteed that rate through the end of August. Next Monday is still August. So through next Monday, it's still at a rate of 10. And I don't know what the total owed is. I'll have to count them up and see how many sessions we've had this summer and so forth. And I'll send her an invoice, or I'll let her know.
All right.
Okay? But otherwise, I'll leave you down on that 3:30 spot, and I will talk to you next Monday.
All right. Talk to you next Monday.
All right. Bye-bye.
Bye-bye.